Hello, class. Let's look at, this is college algebra. Let's look at this problem. I put some good stuff on Learn in my lesson plan about domain this morning, but I didn't do it. This is the toughest problem, so let's look at this one. Domain is such an important concept in algebra, so make sure you guys are looking at my notes and my lesson plan on Blackboard, and of course what I do on YouTube. Okay, so how do we handle this problem? What's the domain going to be? Notice we got to worry about two things here. We got a denominator which we cannot let equal 0, and we have a square root sign, and we can't have a negative number underneath a square root sign. Whenever the index or root is an even number, like here, isn't the index or root 2? If you don't see it, it's assumed to be 2. So you can't have a negative number underneath a radical whose index or root, whatever you want to call it, is an even number, because it will not be in the real number system. If you have an odd number for this root, that's okay. Like, what's the cube root, for instance, of negative 8? The cube root of negative 8 is a real number output. It's negative 2. Isn't it true that if you cube negative 2, you'll get the radicand negative 8? Negative 2 times negative 2 times negative 2 does give you negative 8. So that's something to be aware of. It's okay for a negative number underneath the radical if the index is an odd number, like here it's 3. But if it's an even number, like the square root, the most common radical, then you can't have a negative number underneath the radical. Okay, so let's figure out the domain for this function here. So first things first, let's see for what value of x will make that denominator 0. And do we agree that if x is 5, we're in trouble? Because what's 5 minus 5? 0. When what's the square root of 0? 0. And that means you're dividing by 0. You got 1 over 0, which is undefined. It's not a real number output. It's not a rational number or an irrational number. So that's part of the domain. X cannot equal 5. But we're not done yet. We also have to remember we can't have a negative number inside that square root sign. So all you do to figure out domains with square root signs, write down the radicand, whatever it is, without the square root sign, just the radicand, and always write it as an inequality, greater than or equal to 0. And doesn't that make sense? Doesn't this expression have to be greater than or equal to 0? Yeah, because we want a real number output. And now go ahead and solve this for x. So let's do that right now. I'll subtract 5 from both sides next. So that leaves me with negative x is greater than or equal to negative 5. All I did was subtract 5 from both sides. And now what do we do here? We want to solve for x, not negative x. Let's multiply or divide both sides by negative 1. So that becomes x. Don't forget to flip the inequality sign. Whenever you multiply or divide by a negative number, you must flip the inequality sign. And we have that. So that's the domain for the square root idea. That's the domain for the denominator idea. Now you kind of have to look at these two things together, this and this. And what's the final answer going to be? It's going to be x is less than or equal to 5. I'm sorry, it's going to be x is less than 5. That's the domain for that function. Notice we can't let x equal 5 because of this right here, what we did first. We can't let x be 5, otherwise you have 0 in the denominator. So that's the domain right there for that function. Okay, let's move on to linear equations. Linear equations, it really helps if you know what least common denominator is. How about if I take the numbers 6 and 12? Let's do what's the greatest common factor and what's the least common multiple. Let's make sure we know what these two ideas are. Greatest common factor means what's the biggest number that can go into both of these guys. And I like to look at the smaller number. 6 can go into itself once. Can 6 go into 12 evenly? Yeah, twice. So the greatest common factor is 6. But what's the least common multiple of these two numbers? So we're looking for a bigger number that both of these numbers can go into. So I like to look at the bigger number. 12 can go to itself once. Can 6 go into 12 evenly? Yeah, twice. So that means 12 is the least common multiple there. Okay, what's the least common? Let's do the same thing. What's the least common? Well, let's say greatest common factor and least common multiple of x and x squared. Greatest common factor of these two terms is going to be notice they're like bases, same variable, x. So greatest common factor is one with a smaller exponent. So that's going to be x. Notice x can go into itself once, and how many times can x go into x squared? X times. Isn't x times x equal to x squared? Yeah. And what's the least common multiple of these two terms? Since they have the same base, you pick the one with a higher exponent. So that's going to be x squared. Both of these can go into x squared evenly. X can go into x squared x times, and x squared can go into x squared once. Okay, so that will help with, let's try this problem right here. X over 2 plus 2/3 equals 1/3. So there is an equation, and we want to solve this for x, that numerator right there. So when you have an equal sign, it gives you a lot of power. Let's clear away these fractions by multiplying both sides by the least common denominator, which is the same thing as the least common multiple of the bottom things. So what is the least common multiple of 2, 3, and 3? Looks like 6, right? It's not 3 because 2 can't go into 3 evenly. So 6 is the answer. 3 can go into 6 and 2 can go into 6. So let's multiply both sides of this equal sign by 6. I'll just go like this. That's the same idea. So we should get no fractions now. What's 6 times the first term? Kind of like using the distributive property here. Notice the 2 can cancel with the 6, so isn't that just going to become 3x? If you didn't see that, I'll do it over here. What's 6 times x over 2? What's 6 times x over 2? Multiply fractions straight across. You don't need a common denominator with multiplying fractions, only when adding or subtracting. So multiply the numerator straight across, multiply the denominator straight across. And notice I can cancel factors. 2 goes into 2 once, 2 goes into 6 3 times, and indeed that does equal 3x. So that's what I had here. What's 6 times 2/3? Remember, you got to multiply every term by the 6, both sides, the whole left-hand side and the whole right-hand side. What's 6 times 2/3? Isn't that going to be plus 4? And then equals, and then what's 6 times 1/3? That's 2. Now, these are equivalent equations, this one and this one. But doesn't this look a lot easier to solve for x than this one? This was a lion, and we turned it into a lamb. And if you don't believe me, just listen. Bah! Okay, next, let's subtract 4 from both sides. We want to solve for x, so we want to isolate the x term. So subtracting 4 from both sides, we get 3x equals -2. And then divide both sides by 3, and we get x equals -2/3. And that is the answer right there for that linear equation. Let's do one more of these. How about c over c minus 3, say, equals 3 over c minus 3 minus 3/4. So it's a linear equation because we see an equal sign, linear because everything's degree 1, these variables. So let's multiply both sides by the least common denominator. That makes things a lot easier. So I got a c minus 3 here and a c minus 3 here and a 4 here. So these are like such unlike animals. Like the best I can do for the least common denominator is 4 times c minus 3. That's the least common denominator or least common multiple of the bottom things. Just to check it, how many times does c minus 3 go into this least common denominator? 4 times. How many times does this go into the least common denominator? Doesn't this go into this c minus 3 times? Because what's 4 times c minus 3? That. Okay, so good things will happen. All the fractions will clear when we multiply both sides by the least common denominator, which is 4 times c minus 3. So next step, I'll do the same thing. 4 times c minus 3. That's what we want to multiply both sides of that equal sign by. Okay, so what's this times the first term? Can you see how the c minus 3's cancel? So you get 4c equals, what's this times that term there? Notice the c minus 3's cancel, so you get 12. 3 times 4 is 12. Minus, drop down the minus sign, and what's this times that last term? Notice the 4's cancel, so you get 3 times c minus 3. I'll write it like that, 3 times c minus 3 Okay, next. Let's use a distributive property here to get rid of those parentheses. So I'm going to write 4c equals 12 minus 3c plus 9. Make sure you don't get a sign error. What's a negative 3 times c? Negative 3c. What's a negative 3 times negative 3? Positive 9. Okay, let's continue. We want to solve for c here. Whenever you have variables on both sides of the equal sign, you want to get rid of one of them. Let's add 3c to both sides. So what do we get then? What's 4c plus 3c? 7c equals 12 plus 9? Again, all we did was add 3c to both sides. And let's continue. What's 12 plus 9? 21. So 7c equals 21. And call me a genius, but I believe c is going to equal 3 here. So I'm going to write c equals 3. But before I circle that answer, always make sure it's in the domain of the original problem. Here's the original problem right over here. Right here. What happens though if c is 3? Uh-oh, what's 3 minus 3? 0. You cannot divide by 0. So c equaling 3 is not in the domain. So we must reject this answer and write no solution. Oh, that was a tricky one. All right, everybody. Have fun, have a good weekend, and I'll see you next time.